Imagine walking through a snow-covered valley 60,000 years ago. The air is sharp, the light is fading, and smoke curls up from behind a rocky outcrop. You follow it, and there, crouched around a fire, is someone who looks almost like you. Heavy brow, broad nose, powerful shoulders built for a world of ice and stone. Their eyes meet yours. What do you feel in that moment? Recognition? Fear? Something in between, some ancient sense that you're looking at family, but family from a branch of the tree that split off long, long ago. That moment never happened to any of us directly, but it happened. Somewhere, sometime, our ancestors and theirs stood face to face. And tonight, we're going to walk through the entire story of the people who made that moment possible. The Neanderthals. This is going to be a long, slow journey, and that's exactly the point. If you're here to drift off to sleep, welcome. That's exactly why these stories exist. Let your body settle, let your mind wander, and let the history carry you. If you want to stay with me a little longer before sleep takes over, go ahead and subscribe. And do me a favour, drop a comment telling me where you're listening from and what time it is right now. I read these. It's strange and wonderful. Someone in Sydney getting ready for their morning coffee, while someone in Chicago is pulling the blankets up at midnight, all listening to the same voice, all connected by the same ancient story. It makes this feel less like a video and more like a conversation happening all over the planet at once. So who exactly were the Neanderthals? For a long time, popular imagination painted them as brutish, dim-witted cavemen, more animal than human, stumbling around Ice Age Europe until smarter humans came along and wiped them out. That picture, as we'll see over the next several hours, is almost entirely wrong. Neanderthals were a distinct human species, closely related to us, who lived across Ice Age Eurasia for hundreds of thousands of years. They stretched from the icy forests of what's now Germany and France, down through the Iberian Peninsula, across the Balkans, through the Middle East, and deep into Central Asia, all the way to the Altai Mountains near Siberia. They weren't a footnote in our story. For most of the time they existed. They were arguably more successful at surviving Ice Age Europe than any humans who came before them. They made tools. They controlled fire. They hunted massive animals, cared for their sick and injured, buried their dead, and possibly even created symbolic art. And yet, despite all of that, despite hundreds of thousands of years of survival through repeated ice ages, they disappeared. Not overnight, but gradually, mysteriously, leaving behind bones, tools, and a genetic signature that quietly lives on inside nearly every person of non-African descent alive today. That's the mystery we're going to sit with tonight. How does a species that successful, that adaptable, that deeply human, simply vanish? Was it climate? Was it competition with our own ancestors? Disease or something slower and quieter? A demographic decline nobody at the time could have even noticed happening? We're going to answer these questions using the best evidence available. Archaeology, fossils, and perhaps most remarkably, ancient DNA pulled from bones tens of thousands of years old. Genetic science has completely rewritten what we know about Neanderthals in just the past 2 decades, and we'll walk through those discoveries slowly, piece by piece, the same way scientists did. But before we get to their end, we have to go back to their beginning, back before there were Neanderthals at all, back to the deep roots of the human family tree, where the paths that would eventually lead to them, and to us, first began to split apart. Let's go back, not just decades or centuries, but hundreds of thousands of years, to a time before there was any such thing as a Neanderthal, before there was any such thing as us, when the family tree that would eventually produce both species was still just a single trunk growing somewhere in Africa. Here's something worth sitting with for a moment. When scientists call Neanderthals a distinct species, or sometimes a subspecies, depending on which researcher you ask, they're making a claim that's actually more complicated than it sounds. In paleoanthropology, the word species doesn't work the way it does in a biology textbook definition. Two populations that can't interbreed and produce fertile offspring. Neanderthals and modern humans could interbreed. We know that now beyond any doubt. So were they really a separate species at all, or just a different flavour of us? This is one of those questions that sounds like it should have a simple answer and absolutely does not. Most researchers today land somewhere in the middle. Neanderthals were different enough, in anatomy, in genetics, in hundreds of thousands of years of separate evolutionary history, to be classified as their own species, Homo neanderthalensis. But they were close enough to us that the boundary was porous, permeable, crossable when the opportunity arose. Think of them less like a different species entirely, and more like a distant, distinct branch of the same family. One that grew in its own direction for a very long time before the branches touched again. So where did that branch come from? This is where the story gets a little hazy, and it's worth being honest about that haziness, rather than pretending the fossil record hands us a clean, tidy answer. The leading candidate for a common ancestor, the population that gave rise to both Neanderthals and modern humans, is a group scientists call Homo heidelbergensis. These were hominins living across Africa and Eurasia roughly 700,000 to 300,000 years ago, though the exact dates shift depending on which fossils you're looking at and which lab is doing the dating. Homo heidelbergensis wasn't quite like us, and wasn't quite like Neanderthals either. They had large brow ridges, powerful builds, brains that were already impressively large, though not yet at Neanderthal or modern human size. They made tools. They probably used fire, at least in some populations. They hunted large game with wooden spears, some of which have actually survived, buried in waterlogged sediment for hundreds of thousands of years, an almost unbelievable stroke of preservation luck. Now, here's where we have to be careful, because this is exactly the kind of place where popular science stories tend to oversimplify. Homo heidelbergensis probably wasn't one single uniform population marching in lockstep toward becoming Neanderthals in Europe and Homo sapiens in Africa. It's more likely, based on current fossil and genetic evidence, that heidelbergensis represents a messier, more sprawling group of related populations, some in Africa, some in Europe, some possibly overlapping with other archaic humans we're still trying to properly classify. Paleoanthropology is full of these fuzzy edges, fossils that don't fit neatly into any box, bones that different experts assign to different species depending on which features they emphasize. It's a field built on fragments, literally. A jaw here, a skull cap there, a handful of teeth from a cave in Spain. Piecing together the full picture from evidence this incomplete is a bit like trying to understand an entire novel from a few torn-out pages. You can get the outline of the story, but the details stay stubbornly uncertain. What we can say with reasonable confidence is this. Sometime in this window, likely somewhere between 800,000 and 400,000 years ago, populations of these middle Pleistocene hominins that had migrated out of Africa into Eurasia began to diverge from the populations that stayed behind. The ones in Eurasia, particularly in Europe, found themselves in a very different world than their African relatives. Colder, harsher, subject to the brutal rhythm of the Ice Age's glacial periods advancing and retreating over tens of thousands of years, transforming the landscape again and again. Forests became tundra, tundra became grassland, grassland sometimes became desert, and then, decades or centuries later, forest again. Living through this kind of climate instability wasn't just difficult, it was a relentless selective pressure, favouring whatever traits helped bodies conserve heat, whatever behaviours helped groups survive brutal winters, whatever cognitive flexibility allowed populations to adapt when the landscape around them changed dramatically within a single lifetime. This is the crucible that would eventually forge the Neanderthals. Not a single dramatic event, not one population suddenly becoming a new species overnight, but a long, slow, grinding process, generation after generation, adapting incrementally to an environment that never stayed the same for long. Meanwhile, back in Africa, the populations that had stayed behind were undergoing their own long, slow transformation, one that would eventually produce us, Homo sapiens. Two branches of the same tree, growing in different directions, shaped by different pressures, for hundreds of thousands of years. Now, how do we actually know any of this? It's worth pausing to appreciate the detective work involved, because none of this comes from any single smoking gun piece of evidence. It comes from stitching together several very different kinds of clues. First, there's the fossil record itself, skulls, jaws, limb bones, dug out of caves and riverbanks across Europe, Africa and Asia. Each one a tiny data point in an enormous unfinished puzzle. Then there are the stone tools, which might sound less exciting than bones, but actually tell us an enormous amount. Tool styles changed over time, and archaeologists can track technological traditions moving across regions, evolving in sophistication, splitting into distinct regional variations, the way you might track the spread of a language by looking at dialects. Then there's dating. Modern techniques like uranium series dating and thermoluminescence let scientists pin down, often to a surprising degree of precision, how old a fossil or a tool layer actually is, giving us a timeline to hang all this evidence on. And then, most revolutionary of all, there's ancient DNA, genetic material extracted from fossils tens of thousands of years old, which has, in the past 2 decades, completely rewritten large parts of this story, giving us direct genetic evidence of when populations split, how much they mixed later on, and how closely related they really were. We'll spend a great deal of time on that genetic evidence later, because it's some of the most astonishing science of the past 100 years. But even now it's worth remembering that this deep ancestral story, the slow divergence from a common Middle Pleistocene ancestor, comes from combining all of these evidence types together. Fossils, tools, dates and DNA, each one filling in gaps the others can't reach. So by the time we reach the era Neanderthals proper, the ones with the anatomy we'd actually recognize, the heavy brows, the barrel chests, the massive noses built for freezing Ice Age air, we're already looking at the product of hundreds of thousands of years of separate evolution. Not a moment of divergence, but a process, a slow drifting apart that had been underway since long before anyone alive today's ancestors would have recognized themselves as anything like modern humans. And it's in that long, cold, unforgiving crucible of Ice Age Eurasia that the next chapter of this story truly begins. If you could line up all those Eurasian hominins from, say, 500,000 years ago to 40,000 years ago, and watch them like a time-lapse, you wouldn't see a sudden jump from not Neanderthal to Neanderthal. You'd see a slow, almost imperceptible slide. Generation by generation, certain features would become a little more pronounced, a little more consistent, until eventually, if you paused the film near the end, you'd say, yes, that's them. That's the Neanderthal face. Those hallmark traits weren't arbitrary. Thick, strong limb bones, wide shoulders, a short, stocky torso, a rib cage that flared outward like a bell, faces pulled forward in the middle, with big projecting noses and large sinuses, heavy brow ridges, shading eyes set deep under the forehead, a skull that looked long and low compared to ours, with an occipital bun at the back, a kind of bony bulge where powerful neck muscles anchored. Some of these features very likely helped with the cold. Shorter, stockier bodies with increased muscle mass reduce surface area and conserve heat more efficiently than tall, thin frames. It's the same pattern biologists see in Arctic mammals and even among modern human populations living in cold regions. Those wide nasal passages probably helped warm and humidify icy, dry air before it hit the lungs, reducing damage to delicate tissues. Robust bones, dense and thick, could be an adaptation to a life of enormous physical strain, hauling meat, working stone, hunting large, dangerous animals at close range. But not every Neanderthal trait can be neatly labelled adaptation for cold. Some may have been side effects, traits that came along for the ride as other features were favoured. Others may simply reflect genetic drift, random changes that became common because populations were small and sometimes isolated. Evolution is never a perfectly efficient engineer. It's a tinkerer, working with whatever is already there, constrained by ancestry, chance, and the accidents of history. And history in this case was written by ice. During the hundreds of thousands of years, Neanderthals were taking shape. Europe and Western Asia were locked into a cycle of glacial and interglacial phases. Massive ice sheets would advance southward, grinding over the landscape, lowering sea levels, turning much of the continent into cold open steppe. Then, slowly, the ice would retreat, forests would creep back, rivers would carve new channels, sea levels would rise, drowning old land bridges and creating new coastlines. For the hominins living through this, it meant their world never stayed the same for long. When glaciers advanced, some regions became uninhabitable, forcing populations to retreat into refuges, pockets of livable habitat in southern Europe, around the Mediterranean, or in sheltered river valleys. Groups that once exchanged mates and ideas might find themselves cut off by ice sheets, mountain glaciers, or expanding cold deserts. Isolation like this gives natural selection room to work differently in different places. A behaviour or body type that worked well in one refuge might not be optimal in another. Over thousands of years, those differences could accumulate. Then, as climates warmed and the ice pulled back, corridors reopened. Populations that had diverged now met again, mixing genes, sharing technologies, perhaps competing for the best hunting grounds. This constant rhythm of isolation and reconnection is a powerful engine for evolution. It encourages local specialization, then scrambles the deck, then encourages it again. Because of that, there was never just one Neanderthal template. When you hear Neanderthal, it's easy to picture a single kind of person, a standard model frozen in time. The fossils tell a different story. Neanderthal remains from Western Europe don't look exactly like those from the Near East. Individuals living 130,000 years ago aren't identical to those from 50,000 years ago. Some populations were more robust, others slightly more gracile. Some had particularly massive brow ridges, others a bit less. There are differences in teeth, in the shape of the jaw, in limb proportions. Researchers argue sometimes fiercely about how to interpret these variations. Are we seeing climate adaptation, with stockier builds in colder regions and slightly slimmer frames in milder zones? Are we looking at different population histories with some groups more influenced by earlier immigrant waves out of Africa, others more isolated in European refuges? Or are some of these differences just the normal range you'd expect in any widespread species? To get a sense of this gradual transformation, scientists pay close attention to the so-called early Neanderthals and pre-Neanderthals, fossils like those from Cima de los Huesos in Spain, roughly 430,000 years old, show a fascinating mix of traits. The face and teeth look surprisingly Neanderthal-like. The midface projects, the nasal region is broad, the jaw hints at the heavy, powerful chewing apparatus we associate with later Neanderthals. But the skull vaults the overall shape of the brain case, still has features closer to more general Middle Pleistocene humans. A little later, in sites across Europe and Western Asia, we find skulls and bones that push the anatomy further along that path. By around 200,000 to 130,000 years ago, the classic Neanderthal look is fully apparent in many fossils. Yet even then, here and there we see individuals that blur the lines with combinations of traits that make classification difficult. The boundaries between early Neanderthal, archaic human, and modern human ancestor are not sharp. They're gradients. It's tempting, staring at these bones in a museum case or a textbook illustration, to imagine we know the whole story. Big nose, cold air adaptation, heavy limbs, close-range hunting, thick ribs, tremendous lung capacity, and some of that may be right. But there's a danger in reading behaviour straight off of skeletons. Bones can tell us where muscles attached, how joints moved, what kinds of stresses a body endured. They can reveal injuries healed in life, arthritis from repeated motions, patterns of wear on teeth from diet or using the mouth as a tool. They can hint at stature, at overall build, at brain size and shape. What they can't do, at least not directly, is show us what a Neanderthal day felt like. Did they sleep huddled tight around a fire every night, or only in the coldest months? How did they divide labour between men and women, between young and old? What stories did they tell? What fears did they whisper about the advancing ice? What hopes did they pin on the return of the herds? Even apparently straightforward anatomical features can be surprisingly ambiguous. That big nose might have been useful in cold climates, but it could also reflect deeper developmental constraints inherited from earlier ancestors. Those strong arms might have helped with thrusting spears into large animals, but they might also record a lifetime of scraping hides or hauling wood. There's rarely a single simple explanation. So as the climate beat its slow glacial drum, as populations fragmented and rejoined, as bodies thickened and faces reshaped, what emerged was not some caricatured caveman, but a remarkably specialized human, one tuned to the challenges of Ice Age Eurasia in ways we're only beginning to understand. To really appreciate who they were, though, we have to step out of the bones for a moment and into their landscape. Where did these evolving Neanderthals actually live? How far did they roam, and what kind of world did they call home? Their world stretched farther than most people imagine. If you could unroll a map of Ice Age Eurasia on the ground, Neanderthal country would span from the Atlantic coasts of Iberia and maybe even Britain in some warm phases, all the way east into Central Asia. From the cave systems of France and Germany, across the Carpathians and Balkans, through the Crimea and the Caucasus, down into the Levant and out toward the Altai Mountains of Siberia. A broad arc of land, thousands of kilometers wide, pulsing with life whenever the climate allowed it. But this wasn't a stable kingdom with fixed borders. It was more like a breathing organism, expanding and contracting with the ice. During the coldest glacial peaks, huge ice sheets pressed down from the north. Scandinavia, much of Britain, and large parts of northern Europe were buried under kilometres of ice. South of the ice front, permafrost and treeless tundra made survival difficult for anything that needed more than scattered shrubs and lichens. In those times, Neanderthals pulled back. They seem to have found refuges in places like the Iberian Peninsula, southern France, the Italian and Balkan peninsulas, Greece, the Levant corridor along the eastern Mediterranean, and sheltered valleys in the Caucasus. These pockets of relatively mild climate, with a mixture of woodland and open ground, acted as life rafts. Populations shrank, ranges fractured, but the species held on. Then, as the climate warmed and glaciers retreated, their world opened again. Steppes spread northward, forests crept back over hillsides, rivers surged with meltwater. New grasslands invited the great herds forward. Mammoth and woolly rhinoceros, in the colder phases, bison, horse, and red deer in the milder ones. Neanderthals followed. This cycle repeated over and over across hundreds of thousands of years. Their range was never a single solid block, but a shifting mosaic of occupied and empty territories. Some regions might hold Neanderthal groups for tens of thousands of years. Others were visited, abandoned when conditions turned harsh, and recolonized much later by different bands, perhaps speaking slightly different dialects, carrying slightly different tools. Within this breathing territory, the landscapes they actually used were surprisingly varied. Much of classic Neanderthal land, especially during colder periods, was steppe tundra, wide, open, windswept plains with low vegetation, scattered shrubs, and few tall trees. This wasn't a silent wasteland. It was more like a frozen savanna, rich with grazing animals adapted to cold, reindeer, wild horses, bison. On these plains, visibility was high and cover was scarce. Hunting meant reading the movements of herds across huge distances, knowing where animals would funnel between hills, when they'd come down to water, where snow would crust over and slow them, in slightly milder zones, and during interglacial or interstadial warm pulses, woodlands and mixed forests became more important. Oak, pine, birch, hazel formed patchy cover across hills and river valleys. Here, Neanderthals would have had access not just to large game, but to nuts, fruits, tubers, and small animals. Woodlands offered crucial resources: timber for spears and shelters, bark and fibres for bindings and leaf litter, and branches for bedding and insulation. Closer to the Mediterranean, along coasts and lowlands, the picture changes again. Think of scrubby evergreen woods, rocky hillsides dotted with shrubs, mild winters and dry summers. In these Mediterranean zones, game species included red deer, wild boar, ibex and smaller mammals, along with abundant plant foods and, in some regions, shellfish and fish along the coasts. These areas likely served as key refuges when inland climates swung back toward the severe. Across all of these habitats, seasons mattered, sometimes brutally. In the far north and on the open steppe, winters would have been long, dark, and bitterly cold, with snow cover locking down access to plants and making movement costly. Summer might be short but intense, a rush of growth and animal abundance. Planning had to be seasonal: where to spend the winter, where to intercept migrating herds in spring and autumn, where to gather plant foods in late summer before frost. Rivers were the arteries that tied this world together. Big river systems like the Rhine, the Danube, the Dniester, the Dnieper, and their countless tributaries carved corridors through dense forest and open steppe alike. They offered fresh water, of course, but also predictable travel routes, concentrations of game coming to drink, and rich deposits of raw materials like flint and chert in their gravels. Many Neanderthal sites cluster along these river valleys. It's easy to imagine groups moving up and down a familiar river system over the course of a year, revisiting good shelters, hunting known crossing points, passing information about landmarks and dangers from generation to generation. Mountains, too, shaped their movements. The Alps, the Pyrenees, the Carpathians, the Caucasus, and the Zagros weren't just barriers. They were also reservoirs of diverse microhabitats. South-facing slopes could stay relatively mild even in cold phases, offering plant foods and game when lowlands froze. High passes might be crossed in some seasons and avoided in others. Caves and rock shelters under limestone cliffs provided some of the most famous Neanderthal sites we know. Places like Shanidar in Iraqi Kurdistan, or the caves of southern France and northern Spain. Further north, the ice sheets themselves drew hard lines on the map. You simply could not live under a kilometre of solid ice. The advancing fronts of the Fennoscandian ice sheet turned northern plains into uninhabitable zones. As those fronts moved, Neanderthal groups had to shift as well, pulled back like tidewater ahead of a glacier's grinding edge. Sea levels dropped during glacial peaks, exposing new coastal plains, places like Doggerland, now beneath the North Sea. That may have been rich seasonal hunting grounds when the water was locked up as ice. Over time, different regions within this enormous range developed their own local ways of doing things. Archaeologists see this in stone tools and site organisation. The broad label Mousterian covers many of the stone tool industries associated with Neanderthals, but within that category are regional traditions. In southwestern France and northern Spain, certain patterns of scraper shapes and prepared cores appear again and again. In Central Europe, toolkits emphasize slightly different forms and techniques. In the Levant, assemblages sometimes show blends of Neanderthal-like tools and those more typical of early Homo sapiens, hinting at shared ideas or parallel solutions. These traditions likely reflect both cultural preference and adaptation to local stone types, prey species, and seasonal rhythms. And underneath all of this, the landscape dictated the practical details of survival, where you could find shelter on a stormy winter night, where there was enough wood or bone to feed a fire through the long dark, where water flowed even in dry seasons, where herds reliably passed each year, and where dangerous cliffs or swollen rivers would cut off travel. Neanderthals weren't just wandering aimlessly across a blank Ice Age stage. They were intimately mapped into their world, carrying in their memories a detailed mental atlas. This valley for winter, that ridge for spotting reindeer in spring, that cave mouth as a temporary camp when the rivers flood. Their bodies were shaped by Ice Age climates, but their daily choices were shaped by this constantly shifting geography. To understand them more fully, we have to imagine not only where they went, but who they were as they moved through that world. What did those powerful bodies actually look and feel like in motion? What would it have been like to stand face to face with one of them? If you did stand face to face with a Neanderthal, the first thing you'd notice wouldn't be a monster. It would be a person, but a person built for a different world. Start with the skull. Neanderthal heads were long and low compared to ours. Instead of the high, rounded forehead of a modern human, their foreheads sloped back more gently, giving the whole skull a kind of elongated profile. At the front, heavy brow ridges formed a continuous bar over the eyes, more pronounced than almost anything seen in living populations today. Below those brows, the mid-face projected slightly forward. The nose area was large, the nasal opening wide and tall. The cheekbones didn't flare out to the sides as much as in many modern humans. Instead, the face seemed pulled forward, almost like the front of the skull had been gently stretched. At the back, instead of the rounded dome you might feel on your own head, there was often an occipital bun, a bulge of bone where powerful neck muscles attached. Inside that skull sat a brain that was, on average, as large as or larger than our own, though shaped differently, more elongated, a little less globular. None of this made them stupid or half-formed. It just means evolution had taken them down a slightly different architectural path. The big nose and projecting midface probably weren't random. Most researchers think these features helped condition the air they breathed, warming and humidifying the freezing dry winds of Ice Age Europe before that air hit the lungs. Others suggest the shape reflects chewing stresses from a heavy meat diet or long-term genetic drift. The truth is likely a mix of these factors. What's clear is that this wasn't a primitive face. It was a cold-adapted machine, tuned over hundreds of thousands of years. Move down to the body, and the adaptations become even more obvious. Neanderthals were generally shorter and stockier than most modern humans. Adult males in many regions averaged somewhere around 1.65 meters, adult females a bit less. But those numbers are deceptive, because the key difference wasn't just height. It was build. Their bones are thick, with strong muscle attachments everywhere you look. Upper arms, thighs, hips, ribs all show signs of heavy loading. The long bones of the limbs are slightly curved, like they'd spent a lifetime absorbing the stress of powerful movements. Joint surfaces are broad, built to distribute force. This compact, muscular body plan makes sense in a freezing environment. A lower surface area to volume ratio helps conserve heat. Less gangly limbs sticking out into the cold, more warm core. At the same time, carrying that much muscle comes at a cost: energy. A Neanderthal living through a long glacial winter had to fuel not just a large brain, but a body that burned calories at a high rate simply to stay warm and move effectively. Estimates suggest their daily energy requirements, especially for active hunters, could easily have exceeded those of most modern humans. That implies a diet rich in calories, particularly from animal fat and protein. Their strength wasn't decorative, it was survival. Now, this is where the old stereotype creeps in. For a long time, Neanderthals were drawn as hunched brutes, slouching posture, bent knees, dragging knuckles, vacant stare. Much of that image comes from early reconstructions based on a few individuals who had arthritis and other age-related damage. When you build a species from a single elderly skeleton with spinal problems, you get a misleading picture. Modern analysis paints a different image. Their spines were as upright as ours. Their pelvises were broad but not up-like. Their hands, while strong and somewhat differently proportioned, were capable of precision grips. If you dressed a healthy Neanderthal in modern clothing and had them stand properly, the main thing that would strike you wouldn't be some animalistic posture. It would be the sheer solidity of the frame, the heavy jaw, the deep-set eyes beneath that brow ridge. They weren't cartoon cavemen. They were highly capable humans, physically specialized for an unforgiving climate. What about skin and hair? Here evidence turns softer, more tentative. Bones don't preserve pigment, so we can't look at a skeleton and know its skin color. But ancient DNA, when it survives, gives faint clues. Genetic variants linked to lighter skin and hair in modern Europeans, and some West Asians have been identified in Neanderthal genomes from a few sites, suggesting that at least some Neanderthals may have been pale-skinned, with the possibility of light hair or even freckles. Other individuals may have been darker, their range stretched from cold northern latitudes to relatively sunny Mediterranean and Near Eastern zones, and adaptations to local UV levels likely varied. Hair itself was almost certainly present, body hair patterns similar to ours, scalp hair that may have been thick, possibly wavy. Some genetic hints point toward a tendency to straight hair in certain populations, but here we step into inference. Eye color is even more uncertain. A handful of genetic markers suggest that some Neanderthals could have had lighter eyes, others darker. Overall, the safest picture is this. They would have looked like a varied human population adapted to temperate and cold Eurasia, not a single uniform type. Teeth and bones give us another line of insight, this time into development and health. Neanderthal children seem to have grown quickly in some respects. Microscopic growth lines in teeth, like tree rings, suggest their dental development might have been slightly faster than in many modern humans, though not dramatically so. Their brains reached adult sizes on a similar timetable, maybe with some differences in the pattern of growth. They weren't racing to adulthood in a few short years, but their life history may have tilted a little more toward early physical maturity, a reasonable strategy in harsh conditions where mortality was high. Their skeletons also carry records of their lives: healed fractures, worn joints, repetitive use injuries. Many Neanderthals show signs of significant trauma, especially to the ribs, head and upper body patterns you might also see in modern rodeo riders or big game hunters. The fact that so many of these injuries healed tells us they weren't dying alone on the landscape. Other people were caring for the wounded, feeding them, keeping them warm, giving them time to recover. Even in childhood, stress left marks. Some Neanderthal teeth display lines that indicate periods when growth temporarily slowed, probably during illness or food shortages. These are quiet signatures of hardship, seasons of hunger, outbreaks of disease, sudden cold snaps. But they're also signatures of endurance. The individuals survived those episodes long enough to keep growing. Put all of this together, and a clearer image emerges. A Neanderthal was compact and powerful, with a long, low skull, prominent brow, and projecting mid-face. Their noses were large, their chests barrel-shaped, their limbs short and muscular. They burned a lot of energy and needed a lot of food, but in return they got bodies that could carry heavy loads, endure freezing winds, and wrestle with the demands of Ice Age hunting. They were not lumbering half-beasts, and they were not fragile proto-humans waiting for us to replace them. They were a different way of being human, one that made perfect sense in the landscapes they inhabited. Understanding that physical foundation helps us read the rest of their story more clearly. Because a body that strong, that costly, and that finely tuned to cold doesn't just shape how you look. It shapes how you eat, how you move, how you rest, and how you cope with sickness and injury. To see how those powerful frames were fueled and maintained through long glacial winters, we have to step inside, into the Neanderthal body itself. If you could follow a Neanderthal for a week, not just watch them hunt, but see what actually went into their mouth, you'd probably be surprised by how familiar and how alien their diet really was. For a long time, the story was simple. Neanderthals were almost pure meat-eaters. That picture came from one particular kind of evidence: stable isotopes. When you eat food, tiny chemical signatures from that food end up in your bones. Nitrogen and carbon isotopes in particular shift in predictable ways up the food chain. High ratios of certain nitrogen isotopes usually mean a predator that sits near the top of its ecosystem. Neanderthal bones, especially from colder inland parts of Europe, show isotope values as high as or higher than wolves and big cats from the same sites. That's an extraordinary result. It says they weren't just scavenging. They were functioning as apex predators, regularly eating the meat of large herbivores, bison, horses, woolly rhinoceros, mammoth where available. But those isotopes only tell part of the story. They're biased toward the proteins that end up in bone. Plant foods or fatty tissues barely register in that particular chemical snapshot. For a while, it tempted researchers to talk about Neanderthals as almost exclusively carnivorous. Then other lines of evidence began whispering a more complicated tale. On stone tools inside fire pits, even in the tartar crust on ancient teeth, microscopic residues started turning up. Starches from wild grasses and legumes, traces of nuts and seeds, phytoliths, the tiny silica bodies that plants produce, lodged in dental calculus, chemical traces of smoke and cooked fats. At some coastal sites, fragments of fish bone and shell. So, which picture is right? Meat specialists or broad-spectrum foragers? The answer seems to depend on where and when you look. In glacial steppe environments, with huge herds of large animals moving across open terrain, big game hunting dominated. Stable isotopes, cut marks on bones, and injury patterns all converge. These Neanderthal groups focused intensely on large mammals. They went after red deer in forested valleys, horses on open plains, sometimes even massive proboscideans. The returns, when successful, would have been enormous, hundreds of kilos of flesh and fat, enough to feed a small band for weeks if preserved. But in more temperate regions, and especially in places near coasts or rivers, the pattern broadens. In Iberia, in the Levant, along some Mediterranean shores, there is compelling evidence that Neanderthals ate shellfish, fish, waterfowl, turtles, rabbits, and a wider range of plants. Burned seeds, cracked nutshells, charred tubers show up in hearths. Dental calculus contains granules from cooked grains and roots, some with damage that suggests those plants were heated before being eaten. The variability matters. It means Neanderthals weren't locked into a single strategy. Their bodies may have been built with big game hunting in mind, but their minds were capable of adjusting to whatever local ecosystems offered. All of this ties back to metabolism. A short, heavily muscled body living in sub-zero conditions is expensive to run. Basal metabolic rates in Neanderthals were likely higher than in most modern humans of similar size. Add to that the energy cost of tracking, ambushing, and butchering large animals, and you arrive at a daily calorie requirement that would shock someone used to a sedentary modern life. Think of a Neanderthal winter not as a quiet frozen pause, but as an ongoing economic problem. Can we bring in enough fat and protein, often from dangerous sources, to keep this group warm, moving, and thinking clearly until spring? Their skeletal trauma helps underline the risks involved. Many Neanderthal skeletons show healed fractures of ribs, long bones, and skulls. The pattern is telling. Lots of upper body injuries, the kind you might get from close-range encounters with large thrashing prey or from falls on rough, uneven terrain while carrying heavy loads. One classic comparison is rodeo riders, people who regularly collide with large animals and hard ground. The key word, though, is healed. Broken bones that knit back together, crushed joints that show remodeling, serious head injuries with new bone growth. These individuals survived long enough for the body to repair itself. In a world without hospitals or formal medicine, that survival implies care. Someone else must have shared meat with the injured hunter who couldn't go out. Someone must have helped move them, adjust their sleeping place, bring water, keep firewood stocked. The Neanderthal body, with all its scars and repairs, tells a quiet story of social obligation. Even their teeth preserve traces of this daily struggle with energy and environment. Dental microwear, the tiny scratches and pits that form on enamel, varies between individuals and regions. Some Neanderthals show patterns consistent with chewing tough, sinewy meat and hide. Others show more evidence of grinding hard particles, likely from seeds, nuts, or grit in starchy roots. In some cases, there's a mixed signal, suggesting seasonal shifts: harder, more abrasive foods during lean months, softer or fattier foods when hunting was good. Then there's dental calculus, that hardened plaque that tends to annoy dentists in the modern world and delight archaeologists in the ancient one. Under the microscope, Neanderthal calculus has yielded plant starches, charcoal particles, traces of bitter plants that might have had medicinal value, and even evidence of cooked food. Damage to some starch granules suggests they were heated before being eaten, which not only makes them easier to digest, but also increases the energy you can extract. Taken together, these tiny clues show a species that knew how to process its food, not just grab and gulp whatever was at hand. What about overall health and lifespan? By modern standards, Neanderthal lives were short. Many individuals in the fossil record died in what we would call early adulthood or middle age, with fewer surviving into old age. But that pattern isn't unique to them. It's typical of hunter-gatherer populations living without modern medicine. Skeletal evidence points to episodes of childhood stress, growth lines in teeth, the kind that form when development temporarily slows or stops, show that many Neanderthal children lived through periods of illness, malnutrition, or abrupt environmental change. Some survived those episodes and grew into adults with strong, heavily used bones. Others did not, Disease left fewer obvious traces. Infections that kill quickly don't always scar the skeleton. Still, some Neanderthal remains show sinus infections, dental abscesses, joint inflammation, and possible cases of degenerative disease associated with heavy physical loading. They were not superhumanly healthy. They were humans whose bodies bore the cost of constant exertion in demanding landscapes. Yet health in an Ice Age context doesn't mean the absence of every ailment. It means something closer to functional resilience. Can you grow to reproductive age despite early stresses? Can you keep hunting, gathering, caring for children, travelling with your group even with old injuries and worn joints? Can your community absorb the loss of a skilled hunter or support them through a long recovery? By those standards, Neanderthals were successful for hundreds of thousands of years. Their bones show people who were often hurt, but often healed, frequently stressed, but frequently surviving. Their diets were rich when times were good, desperately stretched when times were bad, and flexible enough to carry them through shifting climates and changing ecosystems. Inside the Neanderthal body, you find no trace of the clumsy caricature. You find a high-powered engine tuned to cold, fed by risk-laden hunts and opportunistic foraging, buffered by social care. And you find the foundations of a daily life that required constant skill with stone, wood, and bone. To see how they turned that energy into tools, and how those tools reflected minds as sharp as their spear points, we have to step out of the body and into their material world. When archaeologists talk about Neanderthal technology, one word comes up again and again: Mousterian. It's just a label, a modern category named after a site in France called Le Moustier. But behind the label lies a pattern. Across Europe and Western Asia, for tens of thousands of years, Neanderthal sites share a recognizable family of tools, pointed flakes that could be used as spear tips, carefully shaped scrapers for working hide and wood, denticulated pieces with little tooth-like edges, notched flakes that seem designed for specific cutting or shaving tasks. What makes this so interesting isn't just the shapes themselves, but how they were made. For millions of years before, stone tools were often created in a fairly simple way. Take a cobble, strike off flakes, use whatever looks sharp enough. Crude hand axes and choppers dominated the landscape. Neanderthals inherited that tradition, but they did something different with it. They perfected a set of techniques that archaeologists group under names like prepared core, and more specifically, levallois. Imagine holding a chunk of flint. Instead of randomly knocking pieces off, you have an end goal in mind, a flake of a particular size, thickness, and shape. To get there, you don't work on the future flake directly. You work on the stone that will give birth to it. Step by step, you shape the core, trimming its edges, preparing a convex surface, setting up a striking platform. Only when everything is just right do you hit it in a precise spot, at a precise angle, with a precise force. If you've done your preparation well, a single blow releases a beautifully shaped flake you can immediately turn into a spear point or scraper. That is levallois. It looks simple on a museum label, but cognitively it's demanding. It requires thinking several steps ahead, holding a mental image of the desired flake, while working on something that doesn't yet look like it. It calls for spatial reasoning, fine motor control, and an understanding of how stone breaks that has been distilled over generations. Archaeologists can see all this in the debris. A Neanderthal living floor buried under thousands of years of sediment can look chaotic at first, stones everywhere, shards of flint, animal bones, ash. But there's a logic to it. People who study stone tools learn to read that logic, the way a musician reads a score. There are cores, the original chunks of raw material, showing the scars of careful preparation. There are flakes, some tiny and accidental, others large, regular, and obviously prized. Sometimes by patiently matching shapes and fracture lines, researchers can refit pieces of stone back together like a 3D jigsaw puzzle, reconstructing the exact sequence of blows a Neanderthal napper used. When those refits are laid out on a table, they tell a story. You can see an individual changing strategies halfway through, correcting a mistake, flipping the core to take advantage of a new surface. You can recognize practiced skill, clean, predictable removals, and you can sometimes detect clumsier attempts, perhaps the work of an apprentice under instruction. The spatial arrangement of these remains tells another part of the story. Heavy cores might be clustered in one area, a napping spot where raw stone was shaped. Retouched flakes and used tools show up near hearths, where hides were scraped, meat sliced, plant fibers processed. Broken spear points turn up at the edges of sites, possibly where weapons were repaired after hunts. From this, archaeologists infer activity areas, napping zones, hide working zones, butchery spaces. A Neanderthal camp becomes less an abstract scatter of artifacts and more a frozen day of work. And stone was only part of the toolkit. Many of the most important components, wooden shafts, bindings, glues, rarely survive. But every so often, the archaeological record gives us a glimpse. At some sites, stone points still carry microscopic traces of plant resin. In others, there are residues of birch pitch, a sticky, tar-like substance that doesn't occur naturally as blobs. You have to make it. To produce birch pitch, you need to heat birch bark in a low-oxygen environment, essentially a controlled distillation. That means containing the bark, managing the fire, maintaining the right conditions long enough for the tar to form and be collected. It's not an accidental byproduct of casually throwing bark on a fire. It's a recipe. Neanderthals used that pitch, along with sinew or plant fibers, to haft stone points onto wooden shafts, to fix knives into handles, to build composite tools that combined at least 3 different materials: stone, wood, adhesive. Holding all of that together is a chain of planning. Someone has to know where birch grows, where good stone can be found, how to shape the point, how to straighten and season wood, how to make and apply pitch, and how to bind everything so it doesn't fail at the worst possible moment. These are not one-off flashes of insight, they are traditions. And if you zoom out across their range, you start to see that there wasn't just one Neanderthal tradition. There were many. In some regions, toolkits are dominated by scrapers and denticulated pieces, suggesting an emphasis on hide processing and woodworking. Elsewhere, more points and backed knives hint at different hunting strategies or prey types. Some areas show heavy use of local stone, picked up within a few kilometers. Other sites contain materials that must have been carried or traded over tens of kilometers, indicating knowledge of distant quarries and perhaps exchanges between groups. Archaeologists give names to these regional variants: Charentian, Quina, and others. But the names are less important than the pattern. Neanderthal technology was flexible. Groups adapted their toolkits to local resources, local prey, local habits. To talk about the Mousterian as if it were a single uniform package is to miss this diversity. Threaded through all of it is time. Prepared core techniques like le Valois don't spring fully formed from a single mind. They require a culture of learning, moments of demonstration and correction, shared standards for what counts as a good tool. A child watches an elder shape a core. They pick up a hammerstone, try to imitate the angle, the force. They fail, produce lopsided flakes, are shown how to adjust. Over years, their hands and eyes learn the subtle feedback of stone, the ring of a good blow, the feel of a platform that's just right. Generation after generation, those skills are transmitted, refined, localized. Minor variations spread through neighbouring groups, innovations appear and either catch on or fade. The stones under our feet become a record not just of survival but of teaching. In that sense, a Mousterian toolkit is more than a pile of tools. It's a snapshot of memory. Each flake, each core bears silent witness to the minds that shaped it, the communities that taught it, the long chain of ancestors who figured out that with the right blow in the right place, you could turn brittle rock into an extension of your hand. To understand how those hands used fire and shelter to carve out livable spaces in bitter climates, we follow the tools into the places where Neanderthals slept, warmed themselves and endured the long Ice Age nights. If you want to understand a species, watch what they do with fire. In Neanderthal sites, again and again, the same pattern appears under the archaeologist's trowel: dark stains in the sediment, lenses of ash, clusters of reddened stone. Bones split open and burned on the outside, but still greasy within. Tiny fragments of charcoal, sometimes so small they look like nothing more than smudges under a microscope. These are hearths. Not just random burn marks from wildfires sweeping through a cave, but repeated localized zones of burning, sometimes stacked one above the other in thin layers of occupation. At some sites there are circular patches a metre or two across, with the highest temperatures in the centre and cooler, lightly baked earth around the edges. Stones lying in the ring show thermal alteration, cracking, reddening, the telltale crazing that comes from being heated and cooled many times. Mixed in with that ash are bones. Some are charred at the ends where they were held too close to the flames. Others burned more evenly, as if roasted. In a few places there's evidence of heated stone technology, rocks deliberately placed in fires and then used while still hot, perhaps to cook in pits or to manage slow, even heating. None of this looks like an occasional, fearful dabbling with a dangerous element. It looks like management habit, fire woven into daily routine. And the context of those fires matters. Neanderthals didn't live only in caves, even if caves are what we picture. They're what the record preserves best, natural shelters that trap sediment and protect delicate remains. So the bias is strong, but scattered across Europe and Western Asia. There are open-air sites too, thin spreads of tools and bone on old river terraces, on wind-blown Loess plains, on the edges of ancient lakes. Caves and rock shelters show us cosy interiors, long-used living floors, hearths renewed in the same spot season after season, activity areas arranged around more permanent features. Open-air sites are more ephemeral, more easily erased by erosion and later occupation. A winter camp on a riverbank, marked by a few post holes and a ring of stones around a fire, can vanish in one flood and leave only a handful of artifacts behind. So when we ask, did Neanderthals build shelters? The fossil record shrugs and gives an incomplete answer. There are hints. At some open-air sites, archaeologists have found arcs of large stones and post holes that might represent windbreaks or simple huts. In cold, treeless environments, groups almost certainly had to improvise. Snow walls, brush screens, frameworks of mammoth bone and hide. Modern humans in similar climates do this as a matter of necessity, and Neanderthals had similar brains, similar hands, and stronger bodies. But strictly speaking, the direct evidence is sparse. What the record does show clearly is that they nested within landscapes. Caves used repeatedly in winter, more exposed locations visited when conditions allowed. Places chosen for shelter from prevailing winds, for proximity to water, for access to migrating herds. Clothing is even harder to see. Skin and fibre almost never survive for tens of thousands of years. There are no Neanderthal coats hanging in museum cases. Instead, we infer from tools and from bodies. Neanderthal skeletons show relatively short limbs and stocky builds, good for conserving heat in cold climates. but not enough on their own to survive glacial winters. At many sites, hide scrapers dominate the toolkit. Under microscopes, the edges of those scrapers show polish and wear traces consistent with long, repetitive work on animal skins. Some tools carry residues of animal fats and connective tissue. That strongly suggests systematic hide working. What exactly those hides became? Loose wraps, fitted garments, boots, sleeping furs, we can't say with certainty. There's no clear evidence of needles with eyes from classic Neanderthal contexts, the kind you'd expect for tight tailoring. So many researchers imagine clothing more like draped and tied layers, perhaps pinned with simple bone or wooden toggles rather than stitched, fitted outfits. Still, in temperatures well below freezing, bare skin doesn't last long. Whatever form their clothing took, it must have been good enough. Fire and hide only work if you can feed them. Fuel in Ice Age Europe came in several forms, and Neanderthals had to think about all of them. In some river valleys and lower elevations there were trees, pine, birch, oak. Wood could be collected as deadfall or cut with stone tools. In more open tundra-like settings, wood was scarce. There, other fuels come into play, dense shrubs, dry grasses twisted into bundles, and, importantly, animal dung. Modern herders in treeless regions burn dung as a regular fuel source. Dried, it smoulders steadily, perfect for maintaining coals through the night. Archaeological sediments from some Neanderthal sites contain phytoliths and chemical signatures suggesting the burning of herbivore dung alongside wood and other plant material. It's not romantic, but it's practical. All of this implies planning. You don't wait until the coldest night to think about fuel. In a Neanderthal winter camp, someone would have been attentive to fire almost constantly, collecting, drying, feeding, banking coals under ash to carry a spark from one day to the next. Birch bark, which we know they used for pitch, also makes excellent tinder. The same knowledge that allowed them to distill tar would have made them expert fire starters. So what did all of this feel like from the inside? Imagine a midwinter evening in a limestone shelter overlooking a frozen valley. Outside, the wind claws at the cliff face, carrying fine grains of snow that hiss and swirl. The light fades early, the sun arcs low and disappears. Inside there's the steady orange pulse of a hearth that has burned in this same spot for generations. Stones around the fire are blackened and cracked from years of heating. In the floor around them lie thin layers of ash and charcoal, each one a memory of past nights. People are gathered close, but not huddled in misery. This is routine. A couple of adults are trimming meat from long bones, the scraps tossed toward the flames. A child toys with a small piece of flint, imitating an elder's napping motions. On the far side of the hearth, someone slowly draws a scraper along a stretched hide, the repetitive motion matched to the gentle rhythm of conversation. Clothing is layered, thick skins draped over shoulders, furs wrapped around legs and feet. Smoke from the fire curls upward, mingling with the musty smell of damp stone, animal fat, and bodies that have moved all day in the cold. Near the shelter entrance, broken spear points and wood shavings mark a repair spot, half in the fading daylight, half in shadow. Every so often someone rises to tend the fire, adding a piece of wood, shifting a dung cake closer to the coals, checking the embers are buried where they'll last until morning. This isn't a special event. It's maintenance, as ordinary as breathing. In that glow, winter shrinks. The vast, hostile landscape outside is pushed back a few meters. Within that circle of light and warmth there is work, rest, food and talk. There is continuity. Tools made the way parents and grandparents made them. Fires kindled in the spots where ancestors once sat. For Neanderthals, survival in long winters wasn't a dramatic daily crisis. It was a practiced craft, mastering fuel, shelter, and warmth well enough that most nights life could unfold in relative comfort. And within that comfort, new possibilities emerged. Time to teach, to remember, to plan the next hunt that would take them out, once again, into the cold. If fire and shelter made life possible, hunting made it meaningful and dangerous. The bones tell the story first. At Neanderthal sites, animal remains don't look like the leftovers from carnivores. They look like the aftermath of organised butchery. Long bones are split lengthwise cleanly and repeatedly to get at the fatty marrow inside. Cut marks etch the surfaces in systematic patterns, fine parallel lines where meat was sliced away from limbs, deeper incisions around joints where tendons were severed to disarticulate the skeleton. On ribs and vertebrae, there are traces of careful work, evidence that people weren't just hacking off chunks, but knowing exactly where to cut to free prime muscles. At some kill sites, entire skeletons of large herbivores are present, but with very specific parts missing or overrepresented. Heads and meaty limbs hauled back to camp, less valuable pieces left behind. This isn't random scavenging off lion kills, it's targeted, efficient, and repeated over tens of thousands of years. And look at which animals dominate those sites. Again and again in Ice Age Europe and Western Asia, large herbivores. Bison, wild horses, red deer, reindeer, in some regions woolly rhinoceros or mammoth. Not just one kind of prey, but a focus on big, powerful animals that could feed a group for days, even weeks, if you could bring them down. Taking on a full-grown bison or a spooked horse isn't something one person does alone on a whim. You don't stroll up with a pointed stick and hope. You need a plan, positions, timing. The landscape becomes part of the strategy. Many Neanderthal kill sites sit near natural bottlenecks, narrow river crossings, canyon mouths, cliff edges, steep ravines, places where moving animals are forced to funnel, where their options shrink. It's easy to imagine small bands of hunters watching the terrain the way a chess player watches a board, learning where herds habitually passed, how they reacted to wind, noise and scent. Some archaeologists think Neanderthals specialised in ambush, a group waiting downwind in scrub or behind rocks, hidden until the last moment. Then a burst of shouting and movement, driving animals into a trap zone where other hunters were ready. A misstep by the prey, a stumble on icy ground or loose stones, and that's the opening. Spears thrust into the flank, the chest, the neck, and those spears matter. We found them, or at least their stone tips and sometimes the shaped wooden shafts. Long, heavy, well-balanced weapons. Edges carefully ground, points resharpened. Microscopic wear on some points suggests they were used to stab into tough targets, not just thrown lightly. That has led many researchers to picture Neanderthals as close-range hunters, driving spears in at arm's length into animals that could kick, trample, or gore them. Other evidence complicates that picture. The aerodynamics of some preserved wooden spears and the shape of certain stone points suggest they were also capable of being thrown, maybe not with the long-range precision of later spear-thrower systems, but far enough to injure and slow prey before the final rush. The debate continues. Were Neanderthals mostly thrusting hunters? Or did they use a mix of thrown and handheld weapons? The answer is probably both, depending on situation and region. But every interpretation agrees on one thing. However they were used, these spears demanded coordination. Whether you stand in a line to receive a charging animal, or circle around to cut off escape routes, your survival depends on knowing what the others are doing, and trusting that they'll be there when it counts. Hunting also had a clock. Large herbivores don't wander aimlessly. They migrate with the seasons, follow fresh grass and unfrozen water, give birth at predictable times of year. At some Neanderthal sites, the ages of hunted animals cluster seasonally. In a given layer, many reindeer killed in late autumn. Just before the hardest cold, at another horse remains from springtime migrations. This suggests they weren't just bumping into whatever wandered past the cave. They were tracking herds over the landscape, returning to the same valley mouths and passes at the right moment, planning movements around when and where prey would be fattest or most vulnerable. Seasonality also meant risk calculations. An injured hunter in late summer, when food is abundant and travel is easy, is one thing. An injured hunter in midwinter, when frequent moves and heavy loads are necessary, is another. And Neanderthals were injured. Their skeletons make that plain. Healed fractures appear all over their bones, broken ribs, damaged pelvises, smashed facial bones, cracked arm and leg shafts. The pattern of injuries looks in some studies unnervingly like that seen in modern rodeo riders, people who regularly come into violent, close contact with large animals. Whatever debate exists about spear throwing versus thrusting, these bodies record the consequences of getting close. A misjudged charge, a step into a hidden hole while running, a horn or antler caught at the wrong angle, collisions with panicked herd mates. But those same skeletons tell a quieter, equally important story. Many of those fractures had healed well enough for the person to live on for years. Some individuals show multiple serious injuries layered across a lifetime. A broken arm from youth, a crushed foot from middle age, vertebrae worn from long, heavy labour. One famous Neanderthal from Shanidar Cave in Iraq had survived massive trauma and disability, including probable blindness in one eye, and yet lived long enough to show advanced arthritis. You don't survive those kinds of injuries alone on a cold steppe. If a hunter breaks a leg in a close-quarters bison hunt, they can't walk for weeks. In a world without hospitals, that means someone else has to carry extra weight, share food, tend wounds, bring water, keep the fire going, watch out for predators. A person with a crushed arm won't be throwing spears anytime soon. They might become a specialist in butchery, in hide working, in childcare. This is where hunting bleeds into social life. Every dangerous encounter with a big animal isn't just a personal risk, it's a test of group resilience. Do you abandon the injured to keep the band mobile or slow down and invest in their recovery? The healed bones say that, very often, Neanderthals chose the second path. So their hunting strategies weren't just about how to kill. They were about how to share the burden of risk, how to turn the unpredictable chaos of wild herds, shifting seasons, and sudden accidents into something a community could absorb. Out on the steppe, the moment of the kill must have been brief and explosive, pounding hooves, shouts, the thud of impact, then stillness. But stretched around that instant, before and after, was a long arc of cooperation, scouting trails, remembering migration routes, teaching youngsters how to move quietly, tending to the injured, carving and sharing meat back at the fire. In that arc, we glimpse a species for whom danger was not just individual courage, but collective knowledge. And that same knowledge, the memories of where animals passed when they carved, how they fell, would shape not only how Neanderthals fed themselves, but how they cared for each other when the hunt was over. Back at the fire, the question becomes, how many people are sitting there with you? For something as basic as group size, the evidence is surprisingly slippery. Archaeologists can count hearths, sleeping depressions, stone tools, food bones. They can map how big a cave floor was, how many individuals' remains lie in a layer. From this, most estimates put Neanderthal living groups at perhaps a dozen to a few dozen people at a time. A handful of nuclear families, grandparents, unmarried siblings, a couple of in-laws. But it's hard to be precise. A site that looks small may just be one camp used by a much larger network, visited for a single season. A big cave full of layers might represent many small groups over centuries, not one large clan at once. Objects move, people move, bones get mixed. What we see in the ground is the blur left by thousands of nights of conversation, sleep and work, with almost all the finer details washed away. Still, patterns emerge. Neanderthal sites rarely look like gatherings of hundreds. There are no great trash heaps thick with settlement debris, no massive storage pits, no built architecture that would suggest big, permanent villages. Their world seems to have been one of small, tight bands, what anthropologists sometimes call face-to-face societies, where you know every person you see, and have known most of them all your life. In groups like that, everyone's business is everyone's survival. The skeletons give us some of the most intimate hints of what that meant. Healed fractures we've already seen. But there's more: severely arthritic joints, badly worn teeth, spines crushed by years of heavy loads. At multiple sites, individuals show long-term impairments that must have limited their ability to hunt or travel. Yet they lived into what, for that era, counted as old age. Some have teeth so ground down or lost that chewing tough meat or roots would have been nearly impossible. One interpretation still debated is that others may have helped process food for them, shredding or cooking it softer. Others showed degenerative diseases in the hips and knees that would have made walking long distances painful. But the bones show long survival after the damage appeared. That implies something simple and profound. People did not discard their injured and frail as soon as they became unproductive. Someone brought them meat. Someone let them rest when others walked. Someone considered their continued existence worth the extra work. You can imagine how that changes the emotional landscape of a small camp. In a band of 20, losing one experienced hunter or one elder storyteller is not a statistic. It is a rupture in the web of relationships, in shared memories of where the herds pass and where the dangerous cliffs lie. Helping a wounded person back to health isn't charity in any modern sense. It's preserving knowledge, keeping the group's mind intact. Children sat right in the middle of that web. Neanderthal infants were born with brains still developing rapidly, just like modern human babies. Raising them in Ice Age Europe was a long, risky project. Small faces peering out from fur wraps, carried from one temporary camp to another, across snow, mud, rocks. Any serious illness, any misstep near a fire or a cliff, could be fatal. For a child to reach adolescence, a lot had to go right. They also had a lot to learn. Tool traditions like the Mousterian didn't spring from instinct. They were taught step by careful step how to choose the right stone, how to strike at the correct angle, how to feel through your fingers when a flake would come off cleanly. Hunting demanded years of practice, first trailing quietly behind adults, then throwing light spears, then finally taking on the dangerous positions at the front. In a tiny community, there are no professional teachers. Training is life. Children would have absorbed knowledge everywhere, at the butchering floor watching how meat is divided, at the fire listening to adults rehearse what went wrong on a hunt, on the move being told which ravines to avoid in thawing weather, which plants sting, which streams freeze last. Under those conditions, every child is an investment of the whole group. Not in a sentimental sense, but in a starkly practical one. There simply aren't enough people for anyone to be expendable. This also shaped how Neanderthal groups moved across their landscapes. They don't seem to have been purely nomadic drifters, nor truly settled villagers. Instead, the pattern that emerges is one of seasonal rounds. certain caves and rock shelters were used again and again over thousands of years. Places with good water, shelter from wind, maybe a reliable view over a migration corridor. These could function as home bases for part of the year. From those bases, smaller parties likely set out to short-term camps, a riverside spot for a week of fishing, a stand of trees where stone or wood was abundant, a valley mouth where reindeer were expected to pass in autumn. The archaeological layers in some regions show this rhythm. Brief scatters of tools and bones in open country, thicker deposits in favoured shelters that saw repeated return. Mobility wasn't just about following animals, it was also about balancing the needs of the vulnerable and the demands of survival. You don't haul someone with a shattered pelvis across 30 kilometres of deep snow unless you have a very good reason and a group willing to bear the cost. That willingness, recorded in bone, suggests routes and schedules were flexible, negotiated within the group, rather than dictated by pure instinct. It would be comforting to say we know exactly how they organised marriages, who lived with whom, whether they had grandparents in a sense we'd recognise, how they resolved conflicts, how they grieved their dead. We don't. The traces are too thin. A cluster of burials might be a family, or might be a sequence of unrelated individuals chosen for the same spot over generations. Genetic studies hint at some patterns of relatedness, but they're snapshots from a few sites, not a complete family tree of a continent. So researchers often turn to analogies with recent hunter-gatherer societies on other continents, with primate behaviour, with general principles of small group dynamics. These comparisons can be useful, but they are also dangerous if pushed too far. Neanderthals were not simply like any living group. Their environments, technologies, and evolutionary histories were their own. What we can say is grounded in the hard evidence, small, closely knit groups rather than sprawling villages, repeated care for the injured and impaired, long demanding childhoods full of learning, seasonal movement across familiar territories. Within those bare outlines, the full richness of their relationships, the jokes, the arguments, the quiet moments between storms, remains largely invisible to us. But it is there, implied in every healed bone and every reoccupied shelter, a species for whom survival was always a collective act. And into that collective, into those circles of firelight and whispered instruction, we can begin to ask a deeper question. How did they share not just tasks and food, but thoughts? What kind of minds were at work behind those heavy brow ridges, and how far could their voices reach? To answer that, we have to start with the machinery. A voice like ours isn't just about having a mouth and lungs. It depends on a whole chain of anatomy, the shape of the throat and tongue space, the position of the larynx, the control of breath, and the fine-tuned muscles of lips and jaw. Most of that doesn't fossilize. Soft tissue rots. Air sacs, vocal folds, tongues, all gone. What we do get from time to time are hints. The base of the skull, where the spine meets the head, tells us something about the angle of the airway. The hyoid bone, a small horseshoe-shaped bone in the throat that anchors tongue and larynx muscles, can sometimes be preserved. In one famous Neanderthal from Kabara Cave in Israel, the hyoid looks strikingly like our own. Not like an ape's, not like a generic early hominins. Like a modern human's on its own, that doesn't prove they had full speech. But it does make it harder to argue that Neanderthals were limited to grunts and hoots. The bony framework that supports complex vocalization seems to have been there. Their ears tell us another part of the story. The tiny bones of the middle ear and the shape of the ear canal affect what frequencies a species hears best. Studies that reconstruct Neanderthal hearing capacities from these bones suggest their hearing range was tuned a lot like ours, particularly sensitive in the band where human speech carries most information. Not just low rumbles, not just high chirps, but the middle range where consonants and vowels live. Again, this doesn't prove language, but it suggests that if they did develop complex vocal communication, their bodies were ready to transmit and receive it. Then there are the genes. One of the most famous is FOXP2, often mislabeled the language gene. In reality, FOXP2 is involved in neural circuits for fine motor control and sequencing, including the control of mouth and hand movements. When this gene is damaged in modern humans, speech becomes halting, imprecise, hard to coordinate. Neanderthals carry a version of FOXP2 that looks essentially the same as ours in the key regions related to speech. That tells us the genetic groundwork for sophisticated vocal control was in place at least by the time our lineage is split. But here's where caution is needed. None of these lines of evidence, bones, ears, genes, tell us what they actually said. They only tell us that Neanderthals were equipped to do something more complex than animal calls. The content, the structure, the richness of that something remains out of reach. So researchers look for another kind of clue: symbols, burials with possible grave goods, pigments like red ochre in cave layers, bird claws with cut marks that might indicate they were strung as ornaments. There are claims of abstract engravings on cave walls that predate the arrival of Homo sapiens, shell fragments with traces of pigment that might have been used as containers for paint. Taken together, these finds suggest that Neanderthals, at least sometimes, treated objects and places as meaningful beyond their immediate use. A feather is not food, a claw is not a tool. If it is carefully removed, kept, worn or buried, it may be standing for something else: identity, status, memory, belonging. But every one of these cases has competing interpretations. Perhaps the pigments were purely functional, used in tanning hides, preserving materials, or as insect repellent. Perhaps the ornaments are the incidental remains of scavenging birds. Perhaps the scratches on cave walls are no more symbolic than claw marks on a tree. This is why the debate about Neanderthal minds can get so heated. The evidence is thin, and the stories we tell about it easily reflect our own expectations. Some scholars emphasize continuity, Neanderthals as humans like us in almost every important way. Others stress difference, a powerful, intelligent species, but with mental worlds organized along unfamiliar lines. One place where their planning depth is hard to deny is in tools and hunting. The prepared core techniques you met earlier, the careful shaping of stone to produce standardized flakes, require holding a sequence of steps in mind and aiming for an abstract goal shape. That's not trial and error in the moment. That's mental rehearsal, planning several moves ahead. Transport of raw materials tells a similar story. At some sites, the flint or chert used for tools comes from tens of kilometers away. Either the Neanderthals carried stone with them as they moved, anticipating future needs, or they maintained knowledge of distant quarries and returned at the right times. Both scenarios imply a mental map of the landscape and the ability to project into the future. Hunting large, dangerous animals at close range demands even more foresight. You don't just run at a bison and hope. You watch the herd, choose the best terrain, coordinate roles, who drives, who flanks, who waits at the choke point. You need signals, whether gestures, eye movements, or words, to shift plans quickly when the animal bolts in an unexpected direction. These are not the behaviours of minds trapped in the present moment. They are minds capable of building scenarios, weighing options, and committing to shared strategies. What then does intelligence mean in this context? Modern humans often measure intelligence with tools that reflect our own lives: literacy, abstract puzzles, the ability to navigate bureaucracies or digital technologies. None of that existed in Ice Age Europe. A Neanderthal's challenges were different. Reading tracks in wind-scoured snow, remembering the migration routes of multiple species across years of shifting climate, knowing which plant roots are safe in late winter and which will sicken a hungry child. A mind optimized for that world might be extraordinary in ways that don't show up on any modern scale. It might have phenomenal spatial memory, exquisite sensitivity to small changes in weather, deep knowledge of animal behavior, yet struggle, if transported to our time, with classroom tests designed around written symbols. So comparisons can mislead. Saying Neanderthals were less intelligent or more intelligent than us is a bit like comparing a seal and a hawk and asking which is the better swimmer. It depends entirely on the medium. Language fits into this same problem of framing. It's tempting to ask a yes or no question. Did they have language or not? But the better way to picture it is as a spectrum. At one end, you have basic vocal calls, like many primates use, a few distinct sounds tied to specific situations. At the other, you have fully modern human language, thousands of words, complex grammar, tense and aspect, storytelling, jokes, hypotheticals. Neanderthals almost certainly did not sit around discussing philosophy in anything like a modern tongue. But it's equally implausible that a species with their brains, their hunting coordination, their care for the injured, and their deep knowledge of landscapes relied only on simple calls. Somewhere along that spectrum between calls and conversations lies their reality. Maybe their speech lacked some of the grammatical complexity of ours, but was rich in gesture and shared context. Maybe they had many words for kinds of snow, rock, or reindeer, and fewer for abstract concepts. Maybe they could talk fluently about where the herd crossed last spring, but not easily about events generations in the past. We don't know the details. What the evidence does suggest is that Neanderthal communication was good enough to support everything else we see: complex tools, coordinated hunts, long childhood training, and social care that extended over years. Behind those heavy brow ridges were minds that mapped their worlds, planned ahead, attached meaning to objects and places, and used voices shaped by familiar genes and bones to keep groups synchronized in dangerous, unforgiving landscapes. In the layers above their camps, another kind of evidence is about to appear. Not just tools and bones, but marks that look less like byproducts of daily life, and more like messages, lines, dots, handprints, arrangements of objects. The question becomes not only what Neanderthals could say to one another now, but what they might have wanted to say to time itself, to leave behind when their own voices fell silent. When those marks first show up in the archaeological record, they don't shout their meanings. They whisper, and often they whisper through layers of doubt. One of the oldest debates centres on pigments. Across Europe and the Near East, Neanderthal sites sometimes yield lumps of red ochre, yellow and black minerals, occasionally ground or scored as if someone had been scraping powder from them. In a few caves, these minerals appear in layers with Neanderthal tools, long before any sign of Homo sapiens. What were they doing with them? The cautious answer is, we don't know. Pigments can be used to tan hides, to preserve organic materials, to protect skin from sun and insects. They can also be used to paint bodies and rocks, to draw symbols, to mark group identity. At some sites, like Maastricht Belvedere or sites in Iberia, the pigments show wear patterns and transport, pieces brought from many kilometres away, accumulated over time. That kind of investment hints at more than casual use. In a few controversial caves in Spain, abstract red markings on stalagmites and walls have been dated by uranium-thorium methods to over 60,000 years ago, apparently older than the earliest known modern humans in the region. If those dates are right, then Neanderthals were making deliberate marks in the dark, dripping interiors of caves. Not just living at the entrance, not just butchering animals on the floor, but going in, placing colour on stone. But this is where stratigraphy and dating become crucial. A tiny error in measuring the age of the calcite crust over a pigment can shift a painting from Neanderthal hands to Homo sapiens hands. Disturbed layers can mix tools and pigments from different times. Water can carry minerals down a wall, blurring original lines. Archaeologists argue about whether some designs might actually be natural stains enhanced by wishful thinking. So each claim is weighed carefully. Is the pigment definitely human applied? Is the layer definitely Neanderthal? Could later people have added colour to earlier rock? The difference between Neanderthal art and art in a cave Neanderthals once used can come down to a few millimetres of sediment. The same problem appears with ornaments. In several Neanderthal sites, researchers have found bird talons with fine-cut marks in just the right places to detach the claw sheath while preserving its shape. Some show polishing or wear on the sides, as if they rubbed against thread or leather. A few sites yield teeth and shells with holes, traces of pigment, or smoothing along the perforation. Are these just butchery leftovers, or were they worn, displayed, maybe tinkling softly against skin and fur? Again, context matters. When multiple claws from the same species show the same careful modifications, when they come from birds whose meat is rarely eaten, and when they appear in association with pigments, the ornament interpretation grows stronger. But the leap from decorative object to symbol is another step. A necklace can be a trophy, a sign of rank, a charm against danger, or it can simply be something that looked pleasing to the wearer's eye. Burials take the uncertainty to an even deeper level. Some Neanderthal skeletons are found in positions that look intentional, flexed, curled, sometimes within shallow pits distinct from the surrounding sediment. At Shanidar in Iraq, one individual lay in a depression later described as having pollen concentrations, which for years was interpreted as evidence of a flower burial. More recent reanalysis suggests that burrowing rodents might have brought in the pollen long after the body was placed. Other sites show stones arranged around a body or animal bones clustered nearby. Are those grave goods, or just the debris of a busy cave floor that later collapsed around a corpse? What most researchers now agree on is that at least some Neanderthals deliberately placed bodies in particular spots, sometimes covering them. That alone implies foresight, a concern with what happens to the dead, a desire to manage decay, perhaps to protect the living or to treat the body with a certain respect. Whether those behaviours were tied to stories of an afterlife, to beliefs about spirits, or simply to practical hygiene is unknown. The emotional weight we feel around graves today may not map neatly onto Ice Age minds. But the pattern, repeated, intentional handling of the dead suggests that a corpse was not just meat, it was someone. Layered on top of all this is the question of contact with Homo sapiens. By the time modern humans reached Europe and Western Asia in larger numbers, they were already making beads, engraving bones, and painting in caves. In some regions, Neanderthal and sapiens occupations overlap or lie only a few centuries apart. Tool styles begin to converge. Personal ornaments show up in levels associated with late Neanderthals that look strikingly like those of their modern human neighbours. Did Neanderthals independently invent similar symbolic practices? Or did they adopt, reinterpret, and weave into their own cultures ideas observed from newcomers? Cultural exchange can be subtle, a way of shaping a blade, a preference for a certain colour, a habit of perforating shells. Convergence is possible too. Different minds, facing similar social needs, arriving at comparable solutions. The truth may be a mix. Just as genes flowed between the groups, so likely did stories, techniques, and perhaps the sense that objects and marks could stand for things not immediately present. Through all of this, one principle holds: we infer, we do not witness. No one alive watched a Neanderthal dip a finger in red ochre and trace a line. No one heard the words spoken over a freshly covered body, if any words were said at all. We reconstruct from fragments scattered in dirt and stone, overlaying them with the least speculative stories we can manage. The safest conclusion is not that Neanderthals lacked symbolism, nor that they possessed it in exactly the way we do, but that their worlds contained layers of meaning we can glimpse only sideways. Pigments, ornaments, burials, and markings form a faint outline of minds for whom colour, object, and place were folded into social life. In the next turn of their story, those minds will meet ours more directly, sharing landscapes, competing for game, sometimes interbreeding, and perhaps for a brief moment in deep time, exchanging not just genes and tools, but ways of seeing the world. For a long time, those questions about meaning and mind had to be answered from bones and stones alone. Then, in the late 20th and early 21st centuries, something quietly revolutionary happened. We learned how to read dust, not the dust you see on a shelf, but the dust of time itself, fragments of DNA preserved in bones that had lain in caves for tens of thousands of years. Most of those molecules had long since broken apart. Water, oxygen, heat, and bacteria shred DNA into tiny pieces, then shred those pieces again. In many fossils, nothing useful is left at all, but in a few places the conditions were kind. Cold, stable caves, deep sediments that stayed dark and relatively dry, dense bones like the petrous part of the temporal bone in the skull, or the inner cores of teeth, where blood vessels once threaded through living tissue. In those tiny shelters, microscopic stretches of genetic code sometimes survived. Recovering them is an exercise in paranoia. A single modern fingerprint has more intact DNA than an entire ancient skeleton. A breath, a flake of skin, a drifting hair can overwhelm the fragile signal from the past. That's why ancient DNA labs look more like clean rooms than archaeological workshops. Researchers wear full-body suits, masks, gloves. Tools are sterilized, reagents treated with ultraviolet light. Samples are drilled from the densest parts of the bone, often from the inside where contamination is least likely. Even then, most of what is sequenced is junk from bacteria and fungi, or from modern humans who handled the bones decades ago. The first task is to separate the ancient from the recent, to recognize the chemical damage patterns characteristic of old DNA, and to assemble millions of tiny fragments into a genome that once belonged to a Neanderthal person. When that became possible, first for bits of mitochondrial DNA, then for whole nuclear genomes, the silence around Neanderthal lives changed tone. Suddenly, bones that had been mute for 40,000 or 70,000 years could tell us who they were related to, how large their populations had been, how healthy their gene pools were. The picture that emerged was not of a thriving, abundant species. Compared to our own history, Neanderthals seem to have lived on a knife edge. Their total effective population size, roughly, the number of breeding individuals contributing genes to future generations, was small, perhaps in the tens of thousands across their entire range, sometimes less. Over and over, the genetic record shows signs of bottlenecks, periods when diversity shrank, lineages winked out, and inbreeding rose. In one famous case, a Neanderthal woman from the Altai region, whose genome has been sequenced in extraordinary detail, turned out to be the child of parents who were as closely related as half-siblings or an uncle and niece. That isn't necessarily typical of every Neanderthal group, but similar signals appear across their genomes. Runs of identical DNA, long stretches where both copies of a gene are nearly the same, hint at small isolated bands marrying within a restricted circle. This doesn't mean that Neanderthals were doomed from the start, but it does suggest that for much of their history they lived in fragmented, vulnerable populations. Local extinctions, recolonizations, and repeated contractions left their demographic story looking more fragile than ours. Ancient DNA also let us ask a different kind of question. Not just how Neanderthals related to each other, but how they related to us. When the first draft of the Neanderthal genome was compared to modern human genomes, one result stood out. People of recent ancestry outside Africa, Europe, Asia, the Americas, Oceania carry small but consistent amounts of Neanderthal DNA. On average, about 1 to 2% of their genomes can be traced back to Neanderthal ancestors. That fraction is small. It does not mean that any modern person is part Neanderthal, in the sense of being a hybrid individual. We are not resurrected Neanderthals in new clothes. What it does mean is that, when modern humans expanded out of Africa and met Neanderthal groups in the Near East and beyond, some of those encounters included sex that led to children, and those children had descendants who survive. Each modern person today carries a different assortment of these ancient fragments. One individual might have a Neanderthal-derived variant affecting keratin in skin and hair. Another might carry a gene version influencing immune responses to pathogens common in Eurasia. A third might possess Neanderthal-derived variants that affect how their body handles fat storage or blood clotting. No one today has enough of these fragments, or the right combination, to recreate a Neanderthal genome within a single person. The pieces are scattered, recombined over thousands of generations. Equally important is what the Neanderthal genome does not show. There is no genetic evidence that Neanderthals were a radically separate, monstrous other. They were close enough to us that interbreeding was biologically easy, and the offspring were fertile. The genetic distance between an early African Homo sapiens and a Neanderthal was greater than between any two people alive today. But it was not a chasm. It was the kind of gap evolution regularly bridges within a single genus. Connecting this genetic story back to archaeology sharpens the outlines of their history. Where stone tools and bones once gave only rough phases, this culture here, that culture there, DNA adds timestamps and family trees. By comparing the genomes of Neanderthals from Spain, Croatia, the Caucasus and Siberia, researchers can trace movements and separations, western and eastern branches splitting, then reconnecting, waves of expansion during warmer phases, contractions during severe cold. In caves, where Neanderthal fossils lie in layers above or below modern human remains, genetic data helps refine the sequence. Did Neanderthals vanish from a region before Homo sapiens arrived? Or did the two populations overlap for centuries, occasionally sharing both tools and genes? Are similarities in artifacts the result of contact, or parallel invention by distant cousins separated long before? Bit by bit, genetics and archaeology are being woven together into a single fabric. The stone point and the gene variant, the burial pit and the inbreeding signal, the pigment fragment and the trace of shared ancestry in a modern immune system, they all tell parts of the same story. A species that endured long climatic swings with limited numbers, that met us more than once, and that left echoes of itself inside our bodies, even after its last distinct communities disappeared from the map. Those meetings, and what followed from them, are where we turn next. When that small group of Homo sapiens left Africa around 60,000 years ago, they weren't stepping into an empty world. To the north and west, across the Sinai and into the Levant, Neanderthals had been living for hundreds of thousands of years. To the east, in parts of Central and East Asia, Denisovan populations occupied their own territories. The map of Eurasia wasn't blank. It was already written in Neanderthal and Denisovan roots, camps, hunting grounds and sacred places. Exactly how the first meetings unfolded, though, is harder to pin down. The timing of our dispersal itself is still being refined. Genetic studies suggest that a major wave of Homo sapiens expansion out of Africa happened around 60–70,000 years ago. Some archaeological sites in the Levant and Arabia hint at earlier, smaller excursions, modern-looking bones and tools more than 100,000 years old. Those earlier pioneers may have met Neanderthals and then vanished, leaving little behind but a few clues in the sand. By the time of the Big Expansion, the Near East was already a kind of borderland. In some phases, Neanderthal remains and tools dominate. In others, it's Homo sapiens. In still others, the evidence is mixed with layers that are difficult to separate finely in time. Sediments shift, caves are reused, a stone tool can be carried and dropped far from its maker. So, instead of a clear line, Neanderthals here, modern humans there, we see a blurred, overlapping frontier. The record from places like the Levant and Caucasus is especially suggestive. In some caves, Neanderthal layers are followed closely by layers with tools usually associated with early Homo sapiens. Sometimes, in the same broad time window, nearby sites show different traditions living side by side. One assemblage dominated by classic Neanderthal Mousterian technology, another showing new tool types, blade-based industries, bone points, ornaments, that are often linked to Homo sapiens. The simplest reading is that, for at least some periods, Neanderthal and modern human groups occupied the same broad regions, perhaps even the same river valleys, within a few days' walk of each other. They may not always have shared the same caves, but their ranges overlapped. In Western Europe, the pattern repeats with a twist. Neanderthals had been the only humans there for a very long time. Then, around 45,000 years ago, give or take a few millennia, new tool traditions appear. Long blades, standardized bone tools, personal ornaments, and more elaborate use of pigments. These are often linked to incoming Homo sapiens, but in several regions there's a brief intermediate phase where Neanderthal remains are found with what look like transitional industries, technologies that mix Mousterian elements with features more typical of those incoming cultures. One interpretation is that Neanderthals, under pressure and in contact with new neighbours, were experimenting, adopting, imitating, or converging on aspects of Homo sapiens technology. Another is that the tools were made by Homo sapiens themselves, moving through landscapes where Neanderthals still lived. A third possibility is that some of these industries reflect communities with mixed ancestry, where ideas and genes were flowing together. Here the genetic evidence helps. We know now that people outside Africa today carry Neanderthal DNA, and that this introgression is not limited to a single event. Genomes from both ancient and living individuals suggest multiple episodes where Neanderthal and Homo sapiens populations interbred, likely in the Near East and perhaps again in Europe and Asia over tens of thousands of years. That doesn't require a world of constant mingling. It only takes a few encounters in a few generations for genetic material to cross species boundaries and then spread. But it does mean that on the ground, some interactions went beyond wary observation at a distance. Those interactions could have taken many forms. In some valleys, groups may simply have avoided each other, using different hunting grounds or seasons, guided by stories about the people on the other side of the ridge. In others, competition may have been sharp, two small bands targeting the same herd of migrating animals, the same watering holes, the same sheltering caves. Aggression between human groups is well attested in later prehistory. It would be surprising if none occurred when two closely related species with overlapping niches met. But the presence of Neanderthal DNA in our genomes, and the hints of shared or rapidly converging technologies, point to more than hostility. Sex that led to children requires at least temporary cooperation, anything from brief encounters between individuals to more enduring relationships between neighbouring bands. If even a few of those children were raised to adulthood within Homo sapiens groups, they carried Neanderthal genes and possibly Neanderthal knowledge into our lineage. Some researchers have suggested that certain tool types or symbolic practices may have moved the other way as well, objects and techniques originating in Homo sapiens contexts, appearing later in Neanderthal layers, or vice versa. The evidence is patchy, and parallel invention is always a possibility. Still, the timing of some shifts, like the appearance of ornaments and pigments in late Neanderthal contexts, lines up suspiciously well with the arrival of Homo sapiens nearby. In a world of small, scattered bands, information was valuable. Knowing a new way to work bone, a better adhesive for hafting, a more effective trapping technique, or a different plant with medicinal properties could make the difference between a lean year and a disastrous one. Occasional friendly exchanges, an evening shared fire, a traded tool, a story told in gestures and speech that was partly understood, may have left traces we can't see directly, but that shaped how both species navigated their changing world. At the same time, demographic realities favoured one side. Homo sapiens populations seem to have been larger and more interconnected, with broader trade and mating networks stretching back into Africa and across their expanding range. Neanderthal groups, as the genetic record shows, were more fragmented and vulnerable. So, when worlds met, the outcomes were probably uneven and varied from place to place. Some encounters left no descendants and no obvious archaeological signature. Others left stone tools that blend traditions, ornaments that appear out of nowhere, and tiny fragments of DNA that are still riding in our blood today. In that long twilight of coexistence, the question was never simply who met whom. It was how often, under what circumstances, and with what consequences for two human species sharing the same fragile, crowded continent. As time went on, that shared continent became less forgiving. The climate of the last ice age didn't move in a smooth line from cold to colder. It pulsed. Sudden warmings and sharp returns to cold, sometimes within just a few centuries. Forests advanced and retreated. Grasslands opened, then closed. Ice sheets thickened, then melted back slightly, then advanced again. Neanderthals had ridden out these swings for hundreds of thousands of years. But in the final stretch of their history, the rhythm changed in a way that seems to have mattered. Around 40,000 years ago, Europe and Western Asia went through some of the most extreme climatic instability of the entire Pleistocene. Short, violent warm phases were followed by brutal cold snaps. Environments could flip from wooded to open steppe and back again within the span of a few human lifetimes. For a species finely tuned to local conditions, this was dangerous. Neanderthals were specialists in many ways. Their bodies, hunting strategies and technologies were superbly adapted to particular combinations of terrain, prey, and seasonality. When those conditions shifted slowly, they could track the changes, move their ranges, adjust their tactics. But when the target kept jumping unpredictably, specialization became a burden. What we see in the archaeological record of late Neanderthals is a world beginning to fragment. Instead of a continuous belt of occupied territory stretching from Iberia to the Altai, we start to see patches, regions where Neanderthals hang on, separated by areas with little or no evidence of them. These patches are what researchers often call refugia, climatic and ecological pockets that stayed relatively stable or at least less harsh when surrounding regions deteriorated. Southern Europe offered several of these shelters. The caves of Iberia, in what is now Spain and Portugal, the limestone systems of southern France, parts of Italy, the Balkans, maybe the Carpathian Basin. To the east, there were likely refuges in the Caucasus and parts of Western Asia as well. In many of these places, Neanderthal occupation persists later than in the colder north. Teeth, bones, and tools remind us that they did not vanish all at once. They retreated, regrouped, and survived for thousands of years in these shrinking islands of habitability. At the same time, their cultural record becomes more complicated. For most of their history, Neanderthals are associated with the Mousterian tradition, a flexible, well-developed stone tool technology that they used successfully across a huge swath of Eurasia. In the last chapters, though, we see industries that don't fit neatly into the old categories. Archaeologists have given them names: Châtelperronian in southwestern France and northern Spain, Uluzzian in Italy, Siletian and others further north and east. These transitional industries mix elements of classic Mousterian with new forms: blades instead of just flakes, decorated objects, bone tools, pierced teeth or shells that may have been worn as ornaments. Who made them is still debated. One camp argues that these are the handiwork of Neanderthals, responding creatively to new circumstances and perhaps to encounters with Homo sapiens. In this view, late Neanderthal communities were not simply stuck in old ways. They were experimenting, borrowing ideas, or independently converging on similar solutions. Ornament use, more diverse toolkits, perhaps broader diets, signs of innovation at the edge. Another camp suggests that many transitional industries reflect the movements of Homo sapiens through regions where Neanderthals still lived. In that case, the mixture we see in the tools may be less about Neanderthals changing and more about two groups' artifacts overlapping in time and space. And then there's the middle position, that at least in some places, mixed communities existed. Bands with both Neanderthal and Homo sapiens ancestry, sharing genes and techniques, producing cultural blends that don't belong fully to one lineage or the other. The evidence is still thin enough that no single picture has won out. What it does tell us, though, is that the final Neanderthal centuries were not static. They were a period of experimentation, contact, and adaptation under pressure. Some key sites bring this into focus. In caves like Saint-Césaire and Grotte du Renne in France, Neanderthal bones are found in layers with Châtelperronian tools and objects some interpret as ornaments. In Iberia, sites in southern Spain and Portugal hint at Neanderthal survival, perhaps a bit later than in northern Europe, with Mousterian traditions persisting at the continent's edge. In the Caucasus and Crimea, late Neanderthal occupations appear in environments that may have been relatively buffered from the worst climatic swings. None of these places show a people passively waiting for extinction. They show persistence, small groups holding on in landscapes that were literally and figuratively closing in. But here, biology and numbers start to matter in a different way. When a species is spread thin, living in small, isolated pockets, its risks multiply even without any single dramatic catastrophe. Each band might be only a few dozen individuals. A harsh winter that kills a handful of hunters. A disease that sweeps through a camp. A low birth rate for a few generations. A bad run of accidents on dangerous hunts. Any one of those is survivable for a large, well-connected population. New members marry in from other groups. Knowledge circulates. Losses are made up in the next generation. For tiny, fragmented populations, though, luck plays a larger role. If a few neighbouring bands fail at the same time because they face the same drought, the same outbreak, the same series of poor hunting seasons, there may be no nearby group to replenish their numbers. Genetic diversity drops. Inbreeding increases. Slight disadvantages accumulate. The result is what some researchers call extinction by 1,000 cuts. Not a comet in the sky, not a single apocalyptic eruption, but many small pressures working together over time. Shifting climates, patchy resources, competition with Homo sapiens, demographic fragility, and the simple mathematics of small numbers. In their final refuges, the last Neanderthals were still doing what they had always done: hunting, gathering, crafting tools, raising children, telling whatever stories they told around the fire. From their perspective, it was just life continuing, one season to the next. From our later vantage point, we can see something else. The map of their world was shrinking. Their territories were being nibbled away. not only by advancing ice and changing vegetation, but by the slow, steady expansion of another human species. As Homo sapiens spread deeper into Europe and Western Asia, those Neanderthal refuges became more crowded, more contested, and more precarious. Climate pulses narrowed the windows of opportunity. Demography limited their ability to bounce back from setbacks. The stage was set for an end that would not be quick and singular, but extended and complex, a fading out driven by multiple forces acting together rather than one simple satisfying cause. So how did that fading actually unfold when researchers talk about Neanderthal extinction? They're really talking about a knot of overlapping processes. No single thread is enough on its own, but if we pull them apart for a moment, 4 big themes appear again and again: climate, competition, disease, and demography. Start with the climate. We've already seen that the last 20,000 years of Neanderthal history were marked by extreme climatic whiplash. Ice core records from Greenland show temperature jumps of 5 to 10 degrees Celsius within centuries, sometimes even decades. For people whose lives were tuned to the behavior of specific herds, forests, and river systems, that kind of volatility is not just uncomfortable, it's destabilizing. One idea, supported by climate models and archaeological gaps, is that rapid warming events temporarily collapsed some of the environments Neanderthals depended on most. Cold steppe herds move, forests thin or shift. Key plant foods no longer appear where they used to. Then the climate snaps back, but not always in the same pattern. Old migration routes break, former hunting grounds become unreliable. In this view, Neanderthals didn't die directly from climate. They died from what climate did to their world, fragmenting habitats into smaller, more isolated pockets, forcing frequent moves, making every year's planning more uncertain. A band that misjudged the seasonal movements of game by even a few weeks could find itself staring at empty valleys. At the same time, another human species was becoming increasingly visible on that broken landscape. Competition with Homo sapiens is often framed like a simple story. We arrived, they vanished. The evidence suggests something more complicated, more drawn out, and more mixed. Think of it as a spectrum of possibilities rather than a single script. On one end of that spectrum is direct conflict, raids, territory defense, perhaps even organized violence. It would be surprising if this never happened. 2 smart, social, heavily armed primates using the same shelters and water sources are unlikely to always resolve disputes peacefully. But we don't have clear, unambiguous battlefields or mass graves that tell a story of large-scale extermination. What we have are scattered hints, some skeletons with trauma, some possible massacres, ambiguous enough that they could equally reflect conflicts within species as much as between them. Move along the spectrum and you reach competitive exclusion without overt war. Here, Homo sapiens may have outcompeted Neanderthals in subtle ways. Slightly higher population growth, slightly better exploitation of certain resources. More flexible social networks that let them buffer bad years by calling on distant allies. More efficient long-distance travel. A broader diet that included fish, birds, plants, and small game at scales Neanderthals rarely exploited. If Homo sapiens groups slowly filled in the best territories, occupied key river valleys, and monopolized certain migration bottlenecks, Neanderthals would be squeezed into poorer habitats. They could still survive there for a while, but each bad decade would hit them harder. Slide further along the spectrum, and you find coexistence and even integration. We know from DNA that Neanderthals and Homo sapiens interbred multiple times. That means there were not only encounters, but relationships, children, and mixed communities. In those places, competition may have looked more like gradual absorption, Neanderthal bands marrying into or being absorbed by larger Homo sapiens networks. Over generations, The distinct Neanderthal genome diluted into a wider sapiens gene pool, even as unmistakably Neanderthal traits persisted in some faces, bodies, and bloodline. In that scenario, Neanderthals didn't disappear in a single clash. They faded genetically, their distinctive form of humanity slowly merging with another. Underlying all of these possibilities is demography, the mathematics of small, scattered populations. Even before Homo sapiens entered the picture, Neanderthals lived at very low population densities. Genetic studies suggest that their effective population sizes were tiny, perhaps equivalent to only a few thousand breeding individuals spread across an entire continent. That doesn't mean there were literally only a few thousand Neanderthals alive at any one time, but it does mean that their genetic diversity was limited and their local bands were small. Small populations are fragile. A single band might have 20 or 30 members, a handful of adult hunters, a few elders, a wave of children. If 2 or 3 adults die in a single winter, an accident on a hunt, a fall, a respiratory infection, that's not just a personal tragedy. It's a blow to the group's long-term survival prospects. Lose a few such bands in neighbouring valleys at the same time, and suddenly there's no one close by to exchange mates with. This is where inbreeding becomes an issue. One famous Neanderthal skeleton from a cave in Siberia comes from an individual whose parents were as closely related as half-siblings or an uncle and niece. That doesn't prove all Neanderthals were severely inbred, but it does illustrate the kind of constrained marriage markets small, isolated groups can face. Inbreeding by itself isn't instantly fatal. Many small populations muddle through it. But it can unmask harmful genetic variants, lower fertility, and increase vulnerability to disease. Over thousands of years, these small disadvantages accumulate, eroding resilience. Now imagine layering other stresses on top of that fragile demographic base. One candidate is disease. Some researchers have proposed that Homo sapiens moving out of Africa with their own suite of pathogens may have introduced diseases to which Neanderthals had little immunity. Just as Eurasian diseases devastated indigenous populations in the Americas after 1492, so too might novel viruses or bacteria have swept through contact zones between Neanderthals and Homo sapiens. At the moment, this remains a hypothesis. Ancient DNA studies of pathogens from this time period are still in their infancy. We don't yet have direct evidence of a specific epidemic that targeted Neanderthals. But in principle, periodically encountering new diseases in small, genetically similar populations is a recipe for sudden, local crashes. Another factor often discussed is technology and social networks. By the later part of the Ice Age, Homo sapiens groups in many regions seem to have developed especially dense and far-reaching networks of exchange. Stone, shells, pigments and ornaments can be traced over hundreds of kilometers. Toolkits became more diversified, projectile weapons that could be thrown or launched from a distance, complex hunting strategies that relied on long-term planning and communication. If Homo sapiens were slightly better at moving information, materials and people over long distances, they could create what some anthropologists call a meta-population safety net. A group that suffered a disaster could be replenished by migrants from far away. Ideas about new hunting methods, new food sources or new rituals could spread rapidly. Neanderthals clearly had social networks. They traded stone over respectable distances, cared for injured community members, and probably had sophisticated communication. But it's possible their networks were more local, less scalable. In that case, their ability to recover from regional setbacks would have been more limited. Put all of this together, and you get a picture that isn't a single cause, but a convergence. Rapid climate swings fragmenting habitats, small scattered Neanderthal populations struggling to maintain genetic diversity and numbers, Homo sapiens groups pushing into the same territories, sometimes competing, sometimes interbreeding, sometimes absorbing. Possible disease exchanges and differences in technology and social connectivity tilting the balance, not overnight, but steadily. Crucially, this extinction wasn't a single date circled on a calendar. It was staggered in time and space. Neanderthals likely disappeared from some northern regions tens of thousands of years before their last holdouts in Iberia or the Caucasus. In some places, they may have been replaced or absorbed quickly within a few centuries of Homo sapiens arriving. In others, they may have coexisted side by side for long stretches, sharing landscapes through multiple climatic pulses. From a distance of 40,000 years, it's tempting to want a neat ending, a final battle, a catastrophic storm, one decisive cause. The evidence keeps pointing us away from that and back towards something more subtle, a gradual thinning of numbers, a patchwork of surviving bands, some merging with newcomers, others winking out quietly. Children with mixed ancestry born in caves where their grandparents had never imagined another kind of human. Stories told around fires in languages we will never hear. As winters lengthened, neighbours changed, and familiar paths grew more dangerous. In that sense, Neanderthals didn't just go extinct like a light switched off. They dwindled, relocated, merged, and finally slipped below the threshold where they were a distinct, self-sustaining lineage. Part of them vanished from the world, part of them kept going inside the people who had helped to end their separate story. So when we say part of them kept going inside us, what does that actually mean? Today, if you have ancestry from outside sub-Saharan Africa, there's a very good chance that somewhere between 1 and a few % of your DNA is Neanderthal in origin. Not in the sense that a great-grandparent was a Neanderthal, but in the sense that a tiny fraction of the genetic instructions in your cells was once carried by someone living in a cold valley 60,000 years ago. Geneticists see this as a pattern, not a myth. When they compare modern human genomes with high-quality Neanderthal genomes, they find little stretches, hundreds or thousands of DNA letters in a row, that match Neanderthal sequences better than they match other modern humans. Those stretches are scattered around the genome like faint fingerprints. They're not evenly distributed. People with ancestry in East Asia, for example, often carry slightly more Neanderthal DNA on average than people with ancestry in Western Europe. Some populations show signs of having inherited multiple pulses of Neanderthal ancestry, meaning interbreeding probably happened more than once, in multiple regions over thousands of years. In Africa, the story is more complex. For a long time, it was assumed that African populations had no Neanderthal ancestry at all, because Neanderthals never lived there. But human history never stays simple for long. Back migrations, groups of people from Eurasia returning to Africa, seem to have carried small amounts of Neanderthal DNA back with them. On top of that, some ancient African populations interbred with other archaic humans who were Neanderthal-like cousins. The result is a subtle, intricate tapestry of shared ancestry that doesn't map cleanly onto modern political or racial categories. Inside that tapestry, some individual Neanderthal variants stand out. One cluster of Neanderthal-derived genes affects the way our immune system recognizes pathogens. These variants seem to have helped early Homo sapiens in Eurasia cope with unfamiliar bacteria and viruses. They were useful enough that natural selection amplified them, spreading them widely through later populations. Other Neanderthal variants influence the way our skin and hair respond to sunlight. Some are tentatively linked to lighter skin tones, sun sensitivity, and the way our bodies manage vitamin D. A few have been associated with keratin, the protein that shapes hair and the outer layer of skin, perhaps reflecting adaptations to cold, dry climates. There are Neanderthal versions of genes that tweak the risk for depression, for blood clotting disorders, for certain autoimmune conditions, even for how easily we wake up at night. Some appear to affect the structure of the nose and face. One Neanderthal variant that persists in some people today may increase the risk of severe respiratory complications from modern diseases. Another may help protect against them. But all of these links come with warnings. Modern genetic studies deal in probabilities and associations, not certainties. When scientists say this Neanderthal variant is associated with increased risk of X, they're not saying that everyone who carries it will develop the condition or that Neanderthals themselves suffered from it. They're noting a statistical pattern in large modern datasets shaped by diets, lifestyles, and environments that Neanderthals never experienced. Genes are context-dependent. The same variant that once helped someone survive a freezing winter might today slightly raise the risk of inflammation in a world of central heating, antibiotics, and processed food. A stretch of DNA that once fine-tuned immune responses to Ice Age pathogens might, in the modern world, nudge the immune system toward overreaction. It's important to keep two clarifications in mind. First, ancestry is not identity. Having 2, 3, or even 4% Neanderthal DNA does not make anyone part Neanderthal in any meaningful cultural or personal sense. Those fragments are diluted across tens of thousands of genes. They don't resurrect a Neanderthal mind or body. They're one thread among many in a deeply mixed human heritage. Second, genes are not destiny. Carrying a Neanderthal-derived variant that nudges some trait, even something as simple as whether you tend to be a morning person, does not lock in a particular fate. Most traits we care about are influenced by dozens, hundreds, or thousands of genes, plus development, plus environment, plus chance. If Neanderthals have left marks on our bodies and brains, those marks are subtle, blended, and endlessly reshaped by life. So what does their legacy actually change? It shifts the way we tell the story of being human. A century ago, Neanderthals were often painted as brutish mistakes, evolutionary dead ends replaced by something better. Today, that picture has softened and deepened. We see them as a different way of being human, cold adapted, powerfully built, living in tight communities, experimenting with tools, pigments, ornaments, and ritual. They weren't us. Their faces, bodies, and probably their social worlds felt different. But they weren't monsters either. They were close enough that our ancestors could fall in love with them, argue with them, raise children with them. Close enough that pieces of their biology still shape how some of us sleep, heal, and respond to winter air. At the same time, it's worth resisting the urge to romanticize. Neanderthals weren't noble savages living in perfect harmony with nature any more than we are villains fated to destroy it. They were Ice Age people doing their best with the knowledge and tools they had, sometimes succeeding brilliantly, sometimes failing, sometimes hurting each other, sometimes caring for each other with astonishing tenderness. Their story reminds us that human has never been a single static category. For most of our history, it was a small family of branches. Neanderthals, Denisovans, early Homo sapiens, intertwined, sharing genes and ideas, shaping each other's fates. Our version of humanity is just the one that happened to still be standing when the others faded. And yet, even now, big pieces of their story remain in shadow. We don't know exactly what languages they spoke, or what they whispered to frightened children on stormy nights. We don't know how they understood the stars or which memories they held most sacred. We're still guessing at the size of their social networks, the details of their rituals, the full range of their creativity. With every new Neanderthal genome, every carefully excavated campsite, every faint pigment stain on a cave wall, that darkness thins a little. New methods for reading ancient DNA from soil and sediment are already revealing traces of people who left no bones at all. Tomorrow's discoveries may overturn some of today's careful reconstructions or fill them in with unexpected colour. For now we lie at the end of a long chain of winters and migrations, carrying inside us small quiet echoes of a people who walked beside us for hundreds of thousands of years. As we drift toward the close of their story, and of ours for tonight, we can follow those echoes back into the last fires they tended, the last valleys they hunted, and the final places where Neanderthals watched their world grow thin. If we trace their story from the beginning to this quiet edge, it has a clear, gentle arc. A small branch of the human family pushed north into harsh climates. Bodies thickening, noses widening, muscles blooming under heavy furs, minds tuning themselves to the rhythm of Ice Age seasons. They learned to hunt giant animals with courage and precision, to tend fires through endless winters, to care for injured elders and fragile children. They shaped stone with patience, organized their camps, watched each other grow, weaken, and die. They buried some of their dead, marked some places with pigment, strong teeth and shells and claws. They lived in worlds of meaning we can sense but not fully translate. Then, very late in their story, another kind of human arrived. Taller, often more lightly built, carrying slightly different tools and slightly different ways of talking, organizing and imagining. For a while, the two kinds lived side by side. They shared genes and probably stories, and almost certainly conflicts. Valleys that had once been only Neanderthal became shared space, and then, over time, stopped being Neanderthal space at all. Their disappearance doesn't look like a single disaster. The evidence points instead to overlapping pressures, layered quietly over thousands of years. Climate shifted again, sometimes quickly, reshaping the forests and plains they knew so well. Herds moved. Ice advanced and retreated. Familiar hunting grounds changed character. Small, scattered populations are fragile in the face of change, and Neanderthal groups were never numerous. On top of that came competition. Our own ancestors may have been better at maintaining long-distance networks, adapting technologies, and filling many different ecological niches at once. In some regions we may simply have eaten into Neanderthal food supplies or out-reproduced them. In others, disease may have played a role, pathogens passing between species with uneven effects. None of these ideas excludes the others. The most plausible picture, based on current evidence, is a slow, uneven fading. Climate stress making life harder, small groups winking out, occasional interbreeding pulling a few surviving lineages into our own, until eventually there were no valleys left where only Neanderthals gathered around the fire. What remains are traces, stone tools in ancient sediments, cave floors packed with ash and bone, genomes read from fragile fragments of bone and teeth. A few % of DNA scattered through modern populations, like embers carried far beyond the place where the fire went out. And around all of that, questions. How did they explain the changing world to their children? How did they see us, these other humans with unfamiliar faces arriving in their hunting grounds? In their last generations, did they feel doomed, or did life still feel ordinary? One more winter, one more hunt, one more story told in the dark. We may never know, but if we listen carefully to the fossils, to the DNA, to the worn edges of stone and bone, we can at least say this: Neanderthals were not a mistake. They were a way that being human could be. For hundreds of thousands of years, they were one chapter in a much broader experiment in human diversity, sharing the planet and eventually sharing genes with us. Tonight, as you fall asleep, you lie at the end of that shared story. Somewhere deep in your ancestry, or in the ancestry of the people around you, there were Neanderthals watching auroras in an Ice Age sky, or listening to wolves in the snow. Their world is gone, but the memory of it lingers in our blood, in our bones, and in our curiosity. If you'd like, you can let that thought be the last thing you hold on to before sleep, that our species is not alone in its history. We are the latest chapter, not the whole book. As you drift off, I'd love to know, what part of the Neanderthal story surprised you most? Was it their strength, their tenderness, their art, their DNA still whispering inside us? If you're listening on YouTube, you're welcome to share your thoughts in the comments, and tell us where in the world you're listening from tonight. If this gentle journey through deep time helped you relax, it really does help when you like the video, leave a comment and subscribe for more quiet history. For now, you can let the questions about Neanderthals float softly in the background and allow your mind to settle, knowing that their story, like ours, is part of a long, intricate, unfinished tale.